Hello, thank you for joining us today. Today we'll be going over the MLOps process at a very high level. So my name is Jonathan Cosme. I'm an AI and ML solutions architect at Run AI. I've been involved in quantitative analytics for about 10 years and have been an avid consumer of GPUs for about 8 years. Today, we're going to go over the process of MLOps, the steps involved, and then we're going to go over what roles and responsibilities are needed in each step. And finally, we're going to describe each step, the maintenance step, the serve step, and the build step in more detail. So let's go ahead and get started. So what is it that we want at the end of the day? Well, this is kind of what we want. We want to be able to maintain a model in production. And so if this is our end step, to maintain the model in production, it follows that the step before this is to actually put the model into production or to serve the model. And before we can actually serve a model, we'll need the model itself. And so the step before this is to build a model. An important thing to note is that I did present this in a linear sort of build, serve, maintain fashion. But the process of MLOps is not linear, and this is a better representation because MLOps is a feedback loop. It's a never-ending process, and you can jump from one step to another without any particular order. In terms of the roles and responsibilities, it is the responsibility of the data scientist to actually build and train the models. The ML engineer arguably has the most difficult job because they have to put the model into production. Sometimes they'll work along software devs or engineers to achieve this if there's maybe like a mobile application that needs to be created. And oftentimes I see organizations hire far too many data scientists and too few ML engineers, if any. And finally, for the maintenance step, it's a coordinated effort between the ML engineers and data scientists, obviously, but also there's going to be some kind of stakeholder who is monitoring how this model impacts some sort of business performance or metric. So in terms of the maintenance step, what is it that we want to do? Well, we want to make sure that our model is meeting some minimum threshold of performance. And we do this by doing two things. One, we monitor. We're going to monitor our model predictions, we're going to monitor our input data, and we're going to monitor user feedback. And we're going to do a lot of retraining. Retraining is critical to the maintenance of our models so that they don't degrade over time. And so one of the things that we can watch is our model predictions over time, and they can help identify warning signs of performance degradation. So for example, if we've got a model that predicts A, B, or C, and we also know the expected frequency of each of these predictions, we can monitor these over several months or weeks or any time frame that you'd like. And in this particular case, we see that in month 4, these expected ranges are breached, and this pattern continues as the months continue. And so this would be a red flag to go back and check our model, see if anything is wrong. In terms of input data, distributions of data often change. And so it's critical to keep an eye on these distributions as well. So something like, say, I don't know, the average age might change over time as life expectancy increases. So you would see the distribution of age shift with time. And so this is critical, important to keep track of because it will affect model performance. Similarly, if I've trained a model with these initial categories, over time we get new categories that the model hasn't seen. And so we have to keep track of this as well because our model needs to be able to handle new data that it hasn't seen before. And in terms of user feedback, it's really common for something like recommender systems to have this kind of feedback, like Netflix or Prime Video, where they ask you if you liked the video that they suggested. And so you might want to keep track of these over time, and maybe you have a threshold of, I don't know, say 85%. And so once that threshold is reached, you want to go back and take a look at your model and see what's going on. And retraining is absolutely critical. So you want to retrain whenever your model is below your performance metric requirement. You want to retrain whenever your input data changes or shifts, or you get new data. You want to retrain when you get user feedback. And it's also good practice just to retrain your model on regular intervals, even if none of these other conditions were met. And once again, this is the responsibility of the ML engineer, data scientists, and the stakeholders. In terms of the serve step, there's a lot that's needed to put a model into production. So we need the model itself. We need a place to put the model. We need a way to get the data into the model, a way to get the model predictions to users, the ability to collect user feedback if that's something we're doing. We need to be able to retrain our models, keep track of all the model versions and the data and metadata, and we want to automate as much as possible. So in terms of the model, we can either put the model on a server or on some edge device. If we put the model on a server, it's easier to set up and maintain, but the disadvantage is that a user can't use the model without a connection to the server. Whereas if we put it on an edge device, it can be used at any time by the user without a connection, but they are more difficult to set up and maintain. So with our data, models require very specific data in a very specific way, and often our raw data isn't model ready. So we've got to set up cleaning methods. We have to transform this data and often normalize it before we can actually get to our nice, clean, model-ready data. And so data processing pipelines have to be set up. And also, depending on the model, we might get some output from the model that isn't user-friendly. So we have to set up transformations to take this raw data and output something that is user-friendly. So post-processing pipelines have to also be created. And in terms of feedback, your users will give you feedback, and hopefully that goes to your server. And so you've got to set up pipelines for capturing this user feedback so that you can use it for your model retraining. And in terms of retraining, we need to create pipelines for retraining on our regular intervals, whenever our data shifts or changes, whenever we get user feedback, and also whenever our model performance isn't up to par. We also need to keep track of all of the changes in our models, in our data as well, in case we have to revert to an older version of a model because there is some error in the new one or the new one becomes corrupted, many different things. And finally, we want to automate as much as possible. This is because, if you've got 10 models, it's a lot easier to keep track of and maintain than say 100 models. So again, whenever and wherever you can, you want to automate things as much as possible. And like I said, this is the responsibility of the ML engineer. They are critical for actually putting models into productions and really making all of the models that you have trained useful for your business. In terms of the build step, we need data. Usually we need labels as well, and we need to be able to transform. We need transformations done on this data before it can be model ready, like we talked about. In terms of a model, we have to consider architecture and also fine tuning. And then finally, we want to be able to reproduce our experiments. Now, in terms of data, it's necessary to apply data transformations to the raw data. And so sometimes we might clean our data to remove values that just can't be, or entries that can't be processed. Oftentimes we will scale our data. We might apply some kind of encoding to our data. And we might also engineer some new features that might help our model have higher prediction accuracy. And another thing to keep in mind and track of is label consistency. This is often an overlooked aspect of of model building. And so here's an example. Let's say we've got this set of instructions, which is draw a box around triangles. Very, very easy set of instructions. And we've got 3 annotators with the similar or same images. Annotator 1 decides to draw his boxes like so. Annotator 2 decides to draw their boxes like so, and annotator 3 draws their boxes like this. And so we can see that none of the annotators did not follow the instructions. They did. They all followed the instructions, but we can see that the same set of instructions can be interpreted many ways by annotators. And if we've got annotations like this that are inconsistent, it will impact the performance of our model significantly. And similarly, if we've got this example where you've got some variation of the text, he has a bad dude, and you've got 2 different annotators, the first annotator might think these people are talking about I don't know, a rock star. And so he thinks, this is a positive thing. He's a bad dude. He's a rock star. He's a cool dude. Whereas annotator two might be thinking that the users are talking about a criminal. And so he might think, oh, he's a bad dude. He's a malicious dude. And he might assign these negative labels. And so you can see that in this particular case, the ambiguity of the word bad can lead different annotators to label the same sentence as opposite sentiments. So, this is definitely something we just want to keep an eye on. In terms of model architecture will depend on the problem. Now, all else equal, we will always prefer a simpler model for the same level of accuracy, because a simpler model, they're faster to train, easier to maintain, easier or perform inference faster, and just use less compute resources overall. Now, if you have a task like, say, autonomous driving, where we need to do inference in real time, it will probably be necessary to sacrifice some accuracy for faster inference speed. Whereas if we're doing something like medical imaging, where we're not getting hundreds of images per minute, and where accuracy really is critical, we're not going to care about inference speed, and we're just going to pick the most accurate model possible. In terms of complexity and explainability, the less complex a model is, the easier it is to explain how some input variable affects the model prediction. Now, model fairness is a new and growing field. And so if you've got something like, say, a model that predicts credit score, you might be limited in the kind of model that you use, because you want to be able to say with a high degree of confidence that your model isn't discriminating against certain underrepresented minorities or something of that nature. And of course, hyperparameter tuning is the aspect that most data scientists are familiar with, where you've got different hyperparameters, different learning rates, batch sizes, maybe different activations, and you're just going to test different combinations of these, whether it's a random search, a grid search, or some Bayesian search to figure out which hyperparameters give you the best performance. And reproducibility is also really important. We want to be able to reproduce the results of any single experiment. And so we have to keep track of all of the data splits, what data split, whether like the test validation, test or training test validation, where each entry went into. We want to keep track of all the changes that we made to our raw data before it was model ready. We want to keep track of all the models themselves, all of the hyperparameters that we used, all of the evaluation metrics that we used, and also the results of those evaluation metrics. So there's a lot to keep track of here. And finally, the data scientist is the one who's involved with the building of models. Thank you so much. I hope you enjoyed our presentation.